Hi everyone, welcome back to the channel. Something a bit more detailed this time. This hub's been sent to me by a friend of the channel who wants me to build it onto a new carbon rim. And I've not had much experience of White Industries T11 hubs, road hubs. I've never built with one before, so I thought it was a good time to strip it down, take a look and see how it's made, look at the materials, look at the bearing arrangement, look at the ratchet, and just work out if there's a good hub or not, or would I recommend it. So starting with the materials, let's start with the body. It's pretty standard aluminium 7075 T6, I think it is. It's quite burly, like the flanges are quite thick, and there's a lot of material around the spoke holes. So the spoke hole PCD is quite a lot smaller than the edge of the flange, and that's nice. There's loads of material above the holes, and we've seen in the past, like when you push that thickness too thin, especially on zip hubs, the tension of the spokes can actually pull through that material and crack it. So it's nice to see thick flanges, plenty of material around the spoke holes. Really nice to see. So that's quite burly, the weight of that body. It's given us, it's aluminium, it's quite heavy. It's not one of the lightest road hubs out there. Moving on to the axle. Very refreshing to see a 15mm axle in steel. Okay, this looks like anodized aluminium, but it's not. It's some sort of chromalloy steel. Really nice to see that, and actually you can see bearing fretting marks here from the free hub bearings. Now imagine if that was aluminium, the galling would be even worse. We'll look at why that's there in a minute, try and decipher why that's occurred. But yeah, again, not the lightest steel axle, but very stiff. This is going to be very stiff, and it's nice to have steel, a hard steel axle running on hardened steel bearings. So the last thing you want is to trash an aluminium axle because it's soft, and it's very hard to get aluminium running on steel bearings reliably without any kind of galling. It seems to be, you know, the fall down of most aluminium parts running on steel bearings. So really nice to see a steel axle. Again, not very light. It does have push-on aluminium end caps. On this end, we've got a adjustable kind of preload collar. We'll come to the preload in a minute when we look at the bearing arrangement. Now, this is up for debate if this is any good or not. Actually, on this one, I've got a bit of a problem when I'm servicing this. This is actually seized. So if I undo these grub screws, basically this aluminium collar should slide, and it's seized onto the shaft. So I need to saw that out. I'll probably put a socket over the end and then give it a tap with a hammer. That should free that off. But at the moment, this isn't actually working because it's seized. This whole assembly is seized at one end. So as a preload collar, it's pretty useless. But I'll get to that. I'll sort that out before I build it back up. Shouldn't be too difficult. And on this side, we've got just a simple push-on end cap with a stop built in. And then other materials. Whilst we're on materials, free hub body, titanium. Obviously, I've still got the cassette on it at the moment. This guy's running a Dura Ace cassette. Don't actually need to take it off to service this. It's easy to get to the bearings. Yeah, titanium free hub. I've said titanium is actually a really nice material to make a free hub from because it's harder than aluminium, but it's much lighter than steel. So the cassette doesn't bite into it as easily as it would if it was aluminium. You know, on the splines on the cassette, if it's not really torqued down really hard, the cassette, you can get those bite marks on the free hub body. Now, my Dura Ace hubs have titanium free hub bodies, and I've not had any bite marks. I've never had like a seized cassette or a cassette that's difficult to get off. So I like titanium. It's a bit blingy for a free hub body, but it seems to be a great material to make out of. So yeah, there's a lot of titanium in my hand at the moment because I think this Dura Ace, these larger cogs on the Dura Ace block, apart from the last 4 or 5 or whatever, they're actually titanium as well, I believe. So yeah, that's pretty cool. Ratchet wise, we've got multi-engaged pulls. There's a couple of steps on these pulls, so they basically double the number of points of engagement for one ratchet tooth, which is quite nice. I never really worry about engagement too much on bike hubs. Unlike mountain bikes, it doesn't seem to be that important because you're kind of on the pedals or off the pedals coasting. It's not like mountain biking or trials riding where you really need a very fine engagement to sort of ratchet yourself over rocks, and you know, you're back pedaling, you're doing technical climbs, you need quick engagement, whereas a road bike doesn't really matter. So I'm not too worried about that. Yeah, but this hub's probably about 4 or 5 years old. I think it's done many thousands of kilometers, and actually it's in really good condition. Yeah, so not much to be said about free hub body That's in really good nick. Now let's get on to, oh yeah, one more thing I want to mention is this is obviously the ratchet teeth inside the hub body. One thing I really like about this hub, which I wish more manufacturers would do, is there's a massive chamfer on the edge of the ratchet tooth there. And what does that do? Well, it makes assembling the thing a doddle. Because of such a large lead in at quite a shallow angle, it's really easy to actually engage the hub. Whereas on some hubs, when you're trying to push the pulls into the ratchet teeth, it's a right pain because they don't put a chamfer on it. Whereas this one, because it's chamfered, it's really easy to drop in. It's a really nice touch actually. Simple, but works really well, so big thumbs up there. So, talked about materials, talked about how burly this hub is for a start, and it's definitely made for endurance. Now, this is where the nitty-gritty stuff comes in for any hub. The important part of any hub is bearing arrangement and preload. So in terms of rear road hubs, there's kind of three main ways that different manufacturers do the preload. They either have no preload on the bearings, which where you get in really, really cheap hubs, and then basically for the angular stiffness of the hub sitting on the shaft, you're at the mercy of all the clearances in the bearings if you don't preload them. Because bearings, one bearing has a radial clearance which translates to an axial clearance, and a kind of a mixture of that will give you a angular slop in the bearing between the inner and outer race. And although you've got 4 in a line in most hubs, when you get right to the edge of the wheel, if you go right to the edge of the wheel, you know, you can feel slop there. So the point about preloading a hub, not only does it makes the bearings last longer, is you can take out all those little clearances in the bearings and make it very stiff at the edge of the wheel, so you don't feel any side-to-side play. So as I mentioned, the first method is to put no preload in, which is pretty shit. The second common method, which you get in quite high-end hubs, is between the inner races of the assembly, you will have very finely toleranced aluminium tube spacers. So all these inner races get locked together by very finely toleranced, lengthwise I'm talking about, aluminium tubes. And then when you clamp it all up with the end caps, all of these little clearances between the inners and outer race get taken up, and all the inner races get locked together on these inner races and between the tubes, and that pinches the whole bearings. But the risk of that is all these lengths of the shoulders where the bearings sit have to be very finely toleranced, and the lengths of the tube spacers need to be very finely toleranced, because if you pinched it all up and let's say one of your tube spacers was too short, you'd deadlock the bearings, you put too much axial load on it, and you'd really create a lot of problems and a lot of drag for the bearings. So that's quite hard to get right, that method. The kind of easiest way to get preload right and have it not reliant on tolerances too much is to do it like White do it. And you basically have a collar on the end of the bearing which can slide on the shaft, sorry, a collar at the end of the shaft which can slide, and then it doesn't really rely then on the individual machining tolerances between all the bearings, because you can just push this up and lock it down, and then it'll take out all of the clearances of the bearings, and you can adjust the preload by basically how much force you push on this cap before you nip down the Allen bolts. So like I mentioned on here, this one's actually seized, so I need to sort that out. But basically you put your bearings, 4 bearings are sat on this shaft. Okay, it's a bit, scale's a bit wrong. I'll bring it closer to the camera, that should sort that out. There we go, look at that, perfect. So then your bearings are sat on the shaft, this collar just touches on the inner race, and by pushing this in, you basically push all the inner races through their axial clearances, and you can take out any clearance and actually add an assembly preload. Now this is kind of like one preload and then you're set. It's like a Shimano bottom bracket. You preload one side, you push it in, and you lock it and you clamp it down with the pinch bolts. It's exactly the same here, apart from these 3 little I think these are M3 grub screws. Now the problem with these M3 grub screws is when I took this out of the hub assembly, these are hard steel grub screws in a soft aluminium collar, and they were very seized. I had to use a bit of heat actually to undo these, and you need to undo these to be able to slide the axle out. So that's one way of applying the preload, and then it's kind of the easiest because it doesn't really matter. The tolerance between these lengths doesn't really matter too much because this can slide. You just push it on, and then basically all the 4 bearings get pinched together on the inner races, and they all share the preload, and essentially you're taking out all the clearances between them. So that's quite a nice method of doing it, and quite a lot of hub manufacturers do this kind of like user set preload, because you don't have to make these very finely tolerant tube length spacers like I think DT Swiss do on DT240s. They have the tube spacers, and then it comes down to very high tolerance machining, which I guess is why you pay for those hubs. So okay, bearing arrangement done, well, preload discussed. So let's look at these bearings. We've got 36902 bearings, pretty standard. The ones in this hub are made by Enduro. Now I don't know if this hub comes with Enduro bearings as standard, and I'm not sure if these have been replaced in their life, but actually they're in pretty good nick, surprisingly. They feel really smooth. Apart from this one, we'll get to that in a minute, but you've got 6902, 6902, 6902. Now the weird thing about the white T11 is they specify a double row angular contact bearing in the free hub. Now traditionally you use an angular contact bearing if you had a lot of axial force, so force in this direction, like a lot of thrust load. Now I'm surprised they've gone for that there. I would probably prefer a bigger normal a single row deep groove ball bearing with a higher radial load rating, because these balls in here are quite small. And actually this bearing is what's called a 3802, and that's a non-standard bearing. So SKF or NTN, they don't make that bearing. This is an Enduro bearing, and I've looked in the SKF catalogue. A 15 ID double row angular contact ball bearing from SKF has a massive OD, much bigger than this. This is a 24 OD, and I think the SKF one, the standard is 40, so that means it has a much larger ball. So these balls in here are actually quite small, and it is weird why they've put this in, because I wouldn't expect a lot of axial force in this part. This part, obviously you've got your cassette up here, this part is taking a lot of radial load kind of in and out of the page from the chain forces and the rider weight going up and down. So I would, if I was the owner of this hub, replace this with 2 6805s, because this width I think is 10mm, and you could put 6805 or 6802? 6802, sorry. You could put 2 6802s in here, which are 5mm wide, to replace this. I would probably do that. It is weird, this non-standard bearing. And actually, if we look at the shaft, that's where we've got the most polishing going, which is the one that goes through that bearing. Now, is that something to do with the ID tolerance of this on this shaft? I don't know. Is it not made that well? I don't know. It's just weird why they've got that there. I just prefer either a much bigger bearing, normal bearing, or just put 2 6802s in. Anyway, moving on. So apart from that, the bearing assembly is pretty simple. This spacer is crucial because it has to preload all of the bearings. These 2 inner races have to touch, and this spacer is quite critical in terms of its width. Now, if we look inside the body next to one of the 6902 bearings, we can see witness marks on the inside of the body here, and that is from the pulls. So what does that tell me? Well, it tells me that when the whole thing's preloaded and the inner races of these bearings shift axially, it tells me that this spacer here is marginally too thin, because the pulls of the ratchet end up touching or just skimming this flat surface. So I would like to see this spacer just being a tickle thicker, because when all these bearings go through their axial clearance and they're all preloaded, obviously the pulls in the free hub end up just touching the anodizing in here, and you get these, you can see these witness marks from that. Now that's not good. They shouldn't do that. Nothing should be touching there. So I'd like to see that bearing maybe 50 microns thicker, because at the end of the day it doesn't matter, because all the slop, if there is any slop after that, can be taken up by the adjustable collar on the end. Now how do you get to that adjustable collar? So when the axle is in the body, you put your 2.5mm Allen key through this little hole. It's really not a nice design actually, because if there's any corrosion in these grub screws and you round off one of the grub screws when it's in there, you're fucked, because how do you get it out? You can't exactly drill it out, because then you've got to put a drill through the hub body. So I'm not massively keen on this method of preload, that these are kind of hidden. Anyway, overall, before this video goes on way too long about hub, there's one other thing I don't like about this hub, which is probably the most alarming, considering that they've actually spent quite a lot of time and effort making this one of the durable hubs in terms of the amount of material, the steel axle. They've specified this weird angular contact bearing. The biggest alarming thing about this hub is that, like I said, they've gone to the lengths of making it durable, but then the very furthest outbound bearing, which is this one, the 6902, when I took this apart, I thought there was something missing. There's basically no weather shield between the back of the cassette and the bearing. So here, normally on a hub you'd have, the end cap would have quite a large flange on it. It might not have a contacting seal, or it might have an O-ring around it, which basically creates just a water seal for this bearing. Well, this one doesn't. It has a very small end cap which pushes up against the inner race, which is fine, but there's no simple weather seal just to stop shit getting in and touching the bearing. Now these are very well sealed LLB bearings, but you really want some sort of extra weather protection just to stop grit and mud going in there, basically, because they do market this as a burly hub, and then they've kind of left that end bearing completely open. So yeah, that's it. It's a weird one, because it's got some real potential, this hub, but it's got some very strange features like I've just mentioned. Anyway, so in total I'd probably give it a 7 out of 10. I still prefer a Dura Ace. Cheers.